Okay, so last time what we were doing, remember, we were looking at the metric system. You know, that's basically what almost the rest of the world uses, except for the United States and two other countries. I don't remember what the two other countries are, but two other countries and the United States uses the imperial system. In fact, in the content section on Blackboard in week 3, I mean, you don't have to read it. There's just a website I posted about the imperial system. I thought it'd be, you know, a fun read. So, but basically the rest of the world uses the metric system. And the metric system, remember, deals with, you know, with with these prefixes. And for length, they use meter. For mass, or really weight is the same thing. If you're staying on one planet like Earth, there is a difference between mass and weight, though. You know, there is a difference, but for now, weight is basically the same thing as mass. And the unit for that is gram. And for volume, they use, or capacity, they use liter. You know, we use gallons, but they use liters. Okay. We also use quarts and pints. You know, we use different units basically. All right. So anyway, we can convert from, in the metric system, we can convert between different units with these prefixes. For instance, here, I was going to have you guys try this out. To go from kiloliters and deciliters to convert, what you want to do is start at deciliters and then you move to kiloliters. So I was going to have you guys try this out. You know, I did go through this last time, not this example, but how to do this last time. It just amounts to moving the decimal. But you know what? Let's just do it together. So I guess, yeah, let's just do it together. Okay. But basically what you have to do, you start at deciliters, because again, we want to know how many kiloliters there are. We want to know how many kiloliters there are in 15 deciliters. So to convert, all you have to do is move, you can think of it as moving the decimal to the left or right. So you start at deciliters, right, 15, and kiloliters is 1, 2, 3, 4 spaces to the left. Okay, so again, you start at deciliters, you're going to move the decimal point 1, 2, 3, 4 units to the left. And so that's what I'm doing here. That's what I'm illustrating. You look at 15, right? Here, let me draw it out with even though it's up here, I feel better drawing it with a pencil or a marker, whatever you call this thing. You're going to move the decimal 1, 2, 3. For the empty space, remember, you got to put a 0. And 4. And that's how we get 0.0015 kiloliters. That's how we get that. I mean, you could write this if you want as a fraction, right? Because the 15 is in the 10,000 decimal place. So you could write it as 15 over 10,000, but you could just leave it as a decimal. That's probably what I would do. So, you know, just to make, why do more work when, yeah, just leave it as a decimal. But again, it's just moving the decimal over. That's actually what's nicer about the metric system, is that because of these prefixes, they just change. They're just based on powers of 10. So converting is a little bit easier. Today, though, we will see how you can convert between the imperial system and the metric system. You know, so basically we'll see more examples of using unit conversions like we did last time. It'll come a little later. Okay, so again, these prefixes, they are nice within the metric system, you know, within, say, length, or here within volume, the different units which change by the prefix. You know, when you go from one of these prefixes to another, essentially you're just changing by a power of 10. That's why we're able to move the decimal the way we are. So, any questions on that? I hope that makes sense. Made sense. Yes.
So like you said it was like deciliters to kiloliters. So like what if
Yeah.
it was like, you know, I guess deciliters to like hectoliter or whatever that is, the one right before
This thing over
kiloliter.
here?
Yeah. So would that just be three?
Exactly. 3 spaces to the left. So you have
Same thing with three. Okay.
0.015.
All
Okay.
right. And if it was like the other way, like
Then
kiloliters
the
to
decimal
deciliters
you
would
would
go
move
the
to
other
the
way?
right. Yeah, you would move the decimal point to the right in that case.
Okay. Yeah, I just wanted to be clear because it was like it's saying like it's like 100 times larger, and I'm like, wait, what's going on? Like, why do I have to move it 100 spaces? Like, that just
Well,
confused
that's the
me.
same as moving it 2 spaces to the right. You're multiplying it by 100, right?
Yeah, yeah, yeah. Okay.
That's why. Okay. I mean, I'm
All
not
right.
sure if the book does it this way with the decimal point. I just thought it was easier, but whatever method you use is correct. You just have to show your work because students did the, I mean, some students, I think, did this last semester. They would use that unit conversions like on the internet, web pages. That's why I like people to show their work, so hopefully that made sense. Okay. Any other questions? Okay. We also have temperature conversions. I mean, if you look on the weather, or I think they have like weather apps. I know I have one on my smartphone. You have a choice between your temperature being in degrees Fahrenheit or degrees Celsius. I know this country uses Fahrenheit. I'm not sure if the rest of the world does, but a lot of other countries use Celsius. But they are related. And the way you convert from one to the other, you're going to use this equation. You actually are not going to use a unit conversion. What we will use is this equation. So that's how they convert from degrees Celsius to degrees Fahrenheit. They use this equation, where F, of course, stands for temperature in degrees Fahrenheit, and C stands for the temperature in degrees Celsius. Can I have one? Oh boy. Stop sharing. Were you guys able to see the screen before?
Yes, now we
Okay.
can't.
Before you were able to, so
Yes,
okay.
now we can again.
Okay. Okay. Good. Just
Strangely
making
enough,
sure.
I can see it still.
What?
I can still see the screen.
Okay. Because I thought it stopped sharing while I was lecturing. So okay. But anyway, that's how we convert though. Okay. So this is just an example. We know that water freezes at 0 degrees Celsius and it boils at 100 degrees Celsius. Okay, so I guess you could take that as a definition if you want. Then how do we know what the corresponding temperatures are in Fahrenheit? In other words, when would water freeze in degrees Fahrenheit? Well, we're just using the equation. We plug in 0 for C, right? In the equation, we have a C here, okay? We plug in 0 for C, right? We multiply by 1.8, then we add 32. And so, of course, just by direct calculation, you're going to get 0 plus 32. So we get 32 degrees Fahrenheit. So that's what we get here. 32 degrees Fahrenheit. Same thing for boiling. Water boiling, right? You just replace where C is. Here we put 0 in. We put 100 in. And, we do the calculation. We multiply by 1.8, add 32, right? And so we end up getting 212 degrees Fahrenheit. Yeah?
So the 0 and the 100 are in Celsius. So we're converting from Celsius to Fahrenheit.
Right. We're putting in temperatures for C, which is degrees Celsius, and F is degrees Fahrenheit.
Okay.
Okay. Awesome question. Any other questions? Okay. We're actually not using unit conversions here. Okay. We're using this equation. Okay. So here's another example. Let's say we want to know what negative 23 degrees Celsius is. We want to know what that is in degrees Fahrenheit. So we want to convert. So here's our equation. Okay. And what we want to do is we take the negative 23 degrees Celsius, we plug it in for C, right? That's what I just did. Then we're going to multiply by 1.8 and add 32. And again, this you could do in your calculator. I mean, I didn't do this in my head. Maybe I could, but I don't know. It would take more time. But anyway, when you do that, you get negative 9.4. So we get negative 9.4 degrees Fahrenheit. So negative 23 degrees Celsius is negative 9.4 degrees Fahrenheit. So we just converted. That's all. Just so quickly. Okay.